So if you've read a tech blog in the last 3 months, you've heard the term big data. It's a buzzword. It means two things when it's a buzzword. One, nobody knows what it is. And two, there's a lot of hype, right? But I think there's a lot of validity in using big data analytics for all kinds of applications. And I'm very passionate about this. The other cool thing about this sort of like hype around big data is that there's a lot of cool tools coming out, things that we couldn't even imagine 2 years ago. And I'm going to talk about one of them today, Google BigQuery. But if you're interested in doing something with data analytics, I'm going to tell you a story. You probably know this story if you've already done this. And if you're thinking about getting into it, you're going to learn this story. So let's start with a single record. Here's a single record. It's easy to work with. It fits on your local workstation. You can develop with it without having to worry about extra hardware or extra infrastructure. And your manager, and in fact, this happened to me last week. My manager came up to me and said, we need to build a data visualization app based on some of the data you have. And I said, great, simple, no problem, right? You just build it. You can use the same kind of web stack you're normally used to, same tools on your workstation, you're fine. Well, it's a hit. Now you're a mobile gamer and you decide, well, I want to build a crowdsourced app that shows you which buildings are best suited for defending against zombie attacks or something, right? So you're using crowdsourced data, a lot of data. Now you have 1 million records. No, wait. Now you really have 1 million records, right? You have a lot of data. Now this is still okay. You can probably handle this on the normal application stack that you have, some of the software that you're using, you're used to. But there's going to be a point where those tools may not work, and that's when you hit something like 1 billion. And now you've got a big data problem. So what are some of the things that you might have to do when you get to billions of records, gigabytes and gigabytes? Well, maybe you shard your traditional MySQL database. Maybe you're buying new software. You're switching from one stack to another. You're going from a relational model to a NoSQL model. Or maybe you're pre-processing data for analytics. So you're running your traditional MySQL database overnight to get some kind of result. And then maybe you need more employee time, or you need more employees. And that's when things get a little crazy. Then your database starts looking like the Borg spaceship, and you've got terabytes of data, and then you're in real trouble, because then maybe you have to rethink your whole system. So let me tell you about scale, right? So as you move from paradigm to paradigm, what happens? Well, you can maybe predict the cost of new storage or instances or virtual machines. There may be a fixed cost there. But I mean, moving from gigabytes to terabytes, moving from paradigm to paradigm, I don't know. Maybe you don't know what it costs. It's hard to predict, right? And new expertise, new exploits, these are things that are hard to predict, right? So the total cost of your scale up is you don't know, right? And so when you don't know, you're not in the application business anymore. You're in the infrastructure business, right? And you're an application developer, right? You're making a game. You're making a crowdsourced mobile app, something like that. So you don't want to be in the infrastructure business. Google's been down this road too, right? When we were called Backrub and we were just a glimmer in a Stanford graduate student's eye, we had 26 million pages in our index, right? But in 2 years later, we had a billion. So our data just scaled enormously, and we had to come up with new tools to handle this. And then it quadrupled in the next couple of years, and then we added an image index. And then by, let's see, 2008, we hit 1 trillion, right? So we've been down this road. And now it's 2012. I think we're at a gazillion. I don't know what the number is. It's huge. Some huge number. So that brings us to Google BigQuery. Okay, so what is Google BigQuery? Google BigQuery is our tool for analyzing massive data sets. It uses a SQL-style language that you may already be used to. It makes it easy to write queries on this data. But the best part about it, as a developer, the thing I love, is it's an API. It's a service. You make calls to it via API. You can use the programming language of your choice. It's a RESTful API. So we use this technology internally. We've written a few papers about it. Internally, we call it Dremel. And you can read the paper, the research paper we publish if you're interested. Without getting too technical, I know this is a lightning talk. I don't have a lot of time, but it's really great information. We basically store the data in a columnar format. And it helps us retrieve these kind of queries quickly. And so I'll show you a demo in just a second. One thing I want to tell you is the way you use it is that you take your data in CSV format and you send it to Google's cloud. Once in there, you can ingest it into the BigQuery data set, and then it allows you to run queries via API. So since this is an API, we're able to actually build a browser client. So when you sign up for BigQuery, you have access to a web browser tool. And that's actually built on top of the API. So it's kind of like a way for us to dogfood our own technology. So I'll show you an example. So here's just a query window. This is a tool that lets you browse queries. You can see I've been playing with this today. There's a lot of queries. I'm going to show you how fast this thing is. This is pretty remarkable. We couldn't do a lot of the things at Google without the speed that this technology allows us to run queries with. The first thing I'm going to show you is a data set of all the revision history of Wikipedia up until about 2010, which is a lot of data. So let's count the records in this data set, and I'll give you a sense of how fast this tool is. So right now I'm running in 2 seconds. In 2 seconds, we return the result. I don't know if you can see it. Make it a little bigger. 313 330 million, yeah, records in that data. So in 2 seconds, we retrieved a count. Now, the fun thing to do with this data set is to see what were the most revised articles, right? Like which articles got the most attention. So let's do this query. This will tell us. Let's run that and see how long this takes. The most revised. Try to think about it before it's already done. George W. Bush. And I'm always fascinated by this, followed by World Wrestling Entertainment employees pages. And I think I know why George W. Bush might be revised a lot. I wasn't sure about the World Wrestling thing. I think it's because there's a lot of fanboys and they like to add new stuff. The plot lines are going on. So I was looking at this data set and I thought, I want to know why these things are revised. So I started looking at the George W. Bush article, and I realized that when people revert due to vandalism, they have a comment in the revision history, reverted due to vandalism. So I wanted to say, well, how many articles were reverted due to vandalism or contained vandalism in the comments? And what's fun about BigQuery is it's so blazingly fast. You can run these ad hoc queries over and over. So let's see if I can find that one. Sorry, I have to zoom out a bit. Oh yeah, here we go. So let's see, vandalism in the revision history comments. The answer may surprise you. 5 seconds, right? So we went through 313 million, 100 million rows in 5 seconds. Yes, George Bush, a lot of comments about vandalism. And then Wikipedia itself, and then Neopets, right? And so I gave this talk at another place, and I said, I would probably vandalize the Neopets Wikipedia article. And then Led Zeppelin, the controversial band Led Zeppelin, and then Adolf Hitler, right? So this is great, right? This just shows you the power of being able to query across these massive data sets. So I'm interested in Wikipedia. One of my coworkers at Google gave me access to a Wikipedia data dump of the actual text. This is just the revision history. That's a very enormous data set. And I'm interested in bias language, right? So that's something I'm interested in, like studying. So I tried to write this web app. Let's see if this thing will work. This is the Wikipedia Weasel Text Finder. So weasel words in Wikipedia are words that have bias language or bias phrases, right? Here, let me actually make this a little bit bigger. Sorry about that. So language like without a doubt or it should be noted. So the Wikipedia editors consider this language to be indicative of bias. So I wanted to see like what articles contain some of this language. So I wrote this app that actually scans the Wikipedia text and in seconds returns articles that contain some of this information. So many are of the opinion. Now let's just pick a random one like Menahem the Yassin. Now if you go to this site, and you can't really see it well, but it looks like somebody has already tagged this as a weasel word, or maybe this is an automated process. I don't actually know. It's a weasel word, so many of their opinion, biased language. So I wanted to go back and see, well, what about articles with it should be noted or without a doubt? Let's take a look. And now I'm scanning the entire Wikipedia corpus in seconds, right? So here we go. Here's a random sampling of articles that contain this biased language. Here's one. It should be noted. So I don't know what this airport is, but it should be noted, and it's not marked as weasel text. So imagine what you could do with this tool, right? You could do a daily scan and look for biased language in seconds, right? And you don't have to worry about the kind of crunching away, buying new servers, et cetera, et cetera. It's all an API, and it's very fast.